The subject name is compiler design. We are going to discuss about a brief overview of syntax directed translation of statements, Boolean expressions, and flow of control statements. So here outcome is syntax directed translation. We are going to understand the depth knowledge about syntax directed translation of statements, Boolean expressions, and flow of control statement. What is the syntax directed translation? The definition, we explained this concept in the previous video. Let us try to understand what is the main, how the translation takes place in case of statements and expression notations. First, initially, what is the translation of assignment statements? Here, while considering this translation of assignment statements, it comes under that is syntax directed translation. Here, the given grammar is S is derives ID equal to I, E1 plus E2, E1 star E2, E derives parenthesis E1 and E derives ID. Now, how the syntax directed translation for the given grammar? See here, for the given grammar, first initially what we are going to consider a 3 address code notation for generation purpose, and while using this temporary names. So we used a lot of temporaries like T1, T2, etc. T1, T2, etc. And we are going to form a syntax tree. In that syntax tree, all the interior nodes, internal nodes, consider as operators and remaining as operands. Like this for every non-terminal, which we are going to describe in the structure. See here, example, that is the left side of the expression, E derives E1 plus E2. E derives E1 plus E2. Now in this E derives E1 plus E2, we are going to compute the value that is a temporary say T. We are going to compute by applying a temporary T, and then that is to be assigned to the left hand side, if at all, if it contains more than one. Now let us see, E has denoted with 2 attributes. Here every non-terminal, each non-terminal, 2 attributes are to be defined in that syntax directed translation of 3 address code. One is E dot place and second one is E dot code. E dot place defines the address holding the value of E. What is the place value? What is the address that can hold in case of that where non-terminal variable E? That is to be catched out by using a notation that is called as E dot place. Another one is E dot code. This code is used to denote the 3 address code for that variable. One is the place value which is holding that, and second one is the 3 address code that is to be generated for that, can be obtained by using this E dot code notation. Now we know that a temporaries are to be allocated for each of the interior purpose for the construction of syntax tree. So these internal nodes are to be used. While construction, we are going to take a function that is called as new temp. Every time a temp is required, so instead of creating a temporaries, we used a function which is going to returns a temporary name. That means, suppose if I create a temp T1, then second time T2, a fresh temporary name is to be created, has to be created with particular purpose. That means we are going to get various temporary like T1, T2, so on, Tn, and where we call new temp. Whenever call a new temp, each time a fresh temporary is to be then concatenation has to be applied for this 3 address code notation. Concatenation has to be applied for the 3 address code notation. Now, see here we know that the true attributes are to be main important points for the consideration of translating a syntax directed 3 address code notation. Now we will see the productions which have considered previously. See, this is the productions which are E1 plus E2, E1 star E2, minus E1. These are the productions which are. So for this, for example, S derives ID equal to E. Now the S is to be considered on the left hand side, that is to be as a semantic action which is to be considered as S dot code. Similarly, the E, variable E dot code. So we know that this is to be concatenated, is used for the generation of the address code whenever the output is to be performed. So how it can be generated? So this is the function generate code. Generate code is the function that is which is equal assigned id dot place equal to. So here this is the holding the place value of id and this is the holding the place value of e. This is holds the address. So here previously we have taken this e dot place, we note down. This contains holding the value of e at particular that variable. So here what is that one? Here id holds the particular address of id and this one holds the address of e. Address of e. So here the two cases, one is holds the place address id and second one holds the address of e. Two cases. Now after this the result has to be displayed immediately by using this function. When you come to the second, E derives E1 plus E2. Now here we are applying a new temp, that means a temporary has been created, that means may T1, say for example, a new temp is being created that is to be assigned to that address of E dot place. Now the right hand side of the expression E1, see that code is to be generated with E dot 1 dot code and the second expression E2 dot code, then the E1 dot code output is sent directly to the E2 dot code and then it is performed and generate code by applying the operation. So here what is the place value of E? E1 dot place, E2 dot place. Then it generates a code with the variable E dot place. That means this is assigned to left hand side of the variable. In the similar way star operation for E derives E1 star E2. Now we have to take one temporary, say a new temp, and we are going to hold the place value of both the variables E1, E2 and code E dot code that is to be generated by applying gen function and then we are going to get the result that is assigned to the left hand side of the expression. Similarly, it is here if you observe there is only one element that is E1. Now we can say a E dot code which is assigned E1 dot code and generation of that place value is E dot place equal to E minus operator unary minus E1 dot place. Now here there is no unary minus operation, that's why it holds the place value and then code value. So if at all if the identifier, only variable identifier itself appears, then place value, code value is not there. So we have to write E dot code equal to null. Simply this is an easy operation which you are going to write the two notations. One is E dot place, second one is E dot code. These are to be mentioned while applying this semantic action. Now, how the Boolean expressions are to be translated into a syntax directed one that can be seen by using this following grammar. Here, one is to it is to be applied with the two main purposes, and one is for computing logical values, and another one is for using conditional expressions if then else while do statement. Conditional express, we know if statement, while structure, and also for computation of logical values like true, false. So in those structures, these two Boolean expressions are mainly useful for the purpose of translating these Boolean expressions. Now consider the grammar. In this, here logical value is OR operator, here logical value is AND operator, here logical NOT, here relational operator, here true, false. Like that, each production contains a different notation of purpose. Then we have to evaluate into a translate or into a syntax direction purpose. Let us see an example here. How it can be translated A or B and C. So first initially we can see here there are two operators. OR is one and another is another operator. One is OR operator and second one is AND operator. Now for the two cases, we are going to simplify the given expression, this Boolean expression, into a three address notation in such a way that it contains at most one operator and three operands. So here the operators are relational operators are and two operators are. So we have to consider in three address sequence notation by applying our previous notation where. So here instead of taking the two operator, we will take first one operator B and C. So that is to be considered as a temporary T1 equal to B and C. Now what happens here? A or what is B and C? T1. Now this is assigned with A or T1 is to be assigned with a new temporal. So this is a three address sequence. This is a three address sequence. Now we can easily convert this expression into a three address sequence. But the three address sequence can be written with the syntax directed translation. Suppose if the expression is, for example, A less than B, then we have to write a code notation such as readdress code notation such as if A less than B go to 4. Here condition is true, less than B. Condition depends on the condition A less than B. Here condition is less than. This is true. Then if the condition is true, then it goes to this fourth step. That means 4 means this step is to be executed. If it is not, that means condition fails. Then it follows, it doesn't go to fourth statement, it goes to the execute the second t equal to 0 and go to 5. What is 5 here? It goes to, that means it skip off 1. That means A less than B, condition true, then executes the state t equal to 1. A less than B, condition false. Then it doesn't go to this fourth. It executes t equal to 0 and then continuation of fifth statement. From fifth statement it has to be cut. Say for example, another example, if you consider in this relational expression, say for example Boolean expression, if you consider that is A less than B or C. A less than B or C. So here A less than B or C. There are three that means one operator, another operator. So we have to cut down into a 3 address sequence in such a way that by writing is convert into a syntax direction. So if at all, if the condition is true, a less than b, true, then it go to this one and verify the condition, that is if it is less than true, yes, t, condition true, then the remaining statements are to be executed. That means the remaining temporary TRC will be executed, t equal to TRC. But if at all, if this is false, that means then it doesn't execute to go to the 4th and 5th. It remains go to the second step, that is t equal to 0, then go to 5. Then it will skip off t1, t equal to 1. Skip off the condition t equal to, this statement won't be executed. So directly it will go to this, go to 5. That means t1 equal to 0. So a less than b, condition is true, then go to some 4th step. Say for example, here 4th step I am writing, that is t equal to 1. Then here condition is true, then this a less than b RC. So it will be execute the remaining also. So that's why TRC also executed. So that is another temporary set T1. So this 5th step will be executed. Say this is the first step. Now if condition is false, this is the second step. That means if condition is true, then this will be executed. If it is false, then it won't go to the 4th step. Control doesn't go to the 4th step. Here control goes to this. That means this is true. Then this is the true case and this is false. So here the control goes to the this step, that is temp t equal to 0. And then we can put another notation, even if it is true or false, then the RC is also to be executed, whether it is a condition. So this R comparison is required whether it is true or false. So that's why here also I can write TRC, but instead of writing TRC, I can directly write what? Go to that step 5 also. That means here the same comparison takes place, T equal to TRC. So in that way we can list out the 3 address code sequence notation where the expressions, that is Boolean expressions, which includes AND operator, OR operator and such other relational operators are also to be evaluated. Say for example here the production rules, which contains various operators such as OR operator, AND operator, NOT, parenthesis E1, ID, relational operator. So all these to be easily translated with a separate 3 address code notation as making a new temporary set T is to be created. So in the sequence of statements also where we created a T, and then a place value of that particular address can get by using variable dot place, which is assigned T, and then we can generate a 3 address code notation by applying, that is E1 dot place, which contains some address, E2 dot place, which contains some address, and by applying this OR operator we are getting that generation of 3 address code notation, and that is assigned to capital T. So here capital T is what? E dot place, where the new temporary has been created. Similarly for AND operation also. AND operator also you can apply E1 dot place, which holds the address of that particular variable E1, and say E2, which immediately holds the address of 3 address notation, E dot 2 place, and then it holds the corresponding value, and then applying AND operator, it generates a notation, 3 address code notation, that is to be assigned to the left hand side variable, what it contains, E dot place, that is equal to T. So which holds the place value of that address variable E, which is assigned to T. Now T is what? It is to be generated with the E1 dot place in E2 dot place. So NOT operation also. Here we are going to create a fresh temporary set T, and this is assigned to e dot place, and then we are going to apply this variable e1 dot place is to be applied, calculate, and then the operator not is to be supplied, and then it generates a new address, 3 address code notation that is to be assigned with e dot place. Now the result is combined with the corresponding not e1. Similarly here parenthesis is just holding the place value and code value, but identifier only the place value, not the code value is not available. Why? Because it is simply as an identifier. Whereas relational operator, if you take relational operator, here we have create one temporary new temp, and that is assigned to a place value of the left hand side, that is which is variable e on the left hand side, which is calculated with the place value of that particular address holding that is t. Now we are going to generate a 3 address code notation with the by applying a relational operator with both identifier 1 and identifier 2. Now here identifier 1 dot place will get holds the value of that place address, which holds address of that place value identifier 1. Similarly, identifier 2 dot place, which also holds address of identifier 2. Now, after performing these two addresses, I am applying identifier 1 relational operator identifier 2. I am applying what? After getting the both the place value of identifier 1 and place value of identifier 2, and then this operator, relational operator, has to be applied. Then we are going to get some result. Suppose if the result is satisfied, that means this entire expression evaluates true, then go to next quad plus 3. Here next quad plus 3 means next address statement, that is here plus 3 means 1, 2, 3. That means it simply go to the generation of t equal to 1. If it is false, evaluates false, then immediately the next state, that is t equal to 0, and quad plus 2. Here quad plus 2 has to be executed. That means immediately the next statement, here statement has to be executed. Next quad statement plus 2. Plus 2 means it will skip off t equal to 1. That means here t equal to 1 when it will be evaluated, here only the true condition only, quad plus 3 this will be evaluated. So at this time this will be skipped off whenever the next quad plus 2 is to be executed. That means t equal to 0 false condition is executed, and false condition this will be executed, and this won't be executed, and this continuation of the statements will be executed. So here in the true case 1, 2, 3, 4, out of the 4 steps, if it is true, then the first statement will be executed, then quad plus 3, that means it will skip off both 2 and 3 and go to 4 and 5 will be executed. That means 5 is consecution of the remaining statements. Whereas in the case of false, then the first statement will be executed, followed by second statement will be executed, followed by third statement, followed by fifth statement. Why? Because t equal to 0, then it will be skip off fourth. Fourth is skipped off. Why? Because it is not executed with that. So this is go to the next question. So like that, the syntax directed code has to be generated as a phase, one of the phase of intermediate code generation for the purpose of translating this Boolean expressions. So we can also write a stepwise manner in the previous example how we written if a less than b, or we can also write as a syntax with the semantic action notation while considering the two attributes, that is e dot place and second one is e dot code. And how the flow of control statements can be translated with the help of this syntax directed translation also we can see with the help of an example. We know that if yes is nothing but a statement, And B is nothing but a Boolean expression, and S sequence of statements, and L is nothing but list of statements, statement list. That means statement 1, statement 2, statement 3, so on, statement M. So there will be, this is called as list of statements. This is called as list of statements. Whereas a single statement or branch of statements, single statement, that is yes. So that is A also considered as one of the assignment statement. Previous video we have taken how the assignment to, that is the right hand side of the expression, can be evaluated and assigned to the left hand side variable, that is to be applied. Now we will see how this expression translation of syntax direct translation of 3 address code notation for translation of flow of control statements. Here also we can use some notation wise format notation where the marker has to be placed. That means here the non-terminal which introduce a marker with the M. So if in case of it is a Boolean expression, a marker is to be introduced, and before the statement, before M is to be put before that statement in both if then else. If then else structure we know. For each if then else structure, before the statement we can put a marker. In case of while structure also, while do while structures are also, we can put before M before E expression where evaluation, we can first put a marker and then evaluation, and then once again we come back to where the execution takes place, and then after continuation of execution the statements list can also be proceed with that help of markers. And if then else evaluates to true and false. For for E evaluation with that one, first statement S will be executed, and then instead of second yes, the code which is then placed after the second will be executed. If then else second S will be executed, then we can place another non-terminal with marker N after the first. So like that, a code divisibility applied with the help of these markers, and then the statement expression is, say here attributes we applied is B dot true, some label is to be assigned. So here list of statements are there, statement 1, statement 2, statement N. So here a marker is to be placed, that means a label. So M is to be kept. So before M we can have some statements, and we are going to evaluate some expressions. After that we can come back and execute. So here the control flow where the label appears true, so that is to be applied as B is true. That means here a marker, suppose B dot true has been introduced, this list of statements, from this list of statements the marker is applied, that is all the statements as B dot. Suppose if the label is marked as a false, then that control flow belongs to the false value. So you may apply, that is BRS, that is statements or branches, and next S dot next, which is used for generating the next 3 address code for the following 3 address code of S. Let us see an example how this markers has been introduced for calculation of this 3 address code notation with the help of this if else structures. See here the first structure is if S implies if B statement. Here we know that this is a Boolean expression. This Boolean expression is to be evaluated. This B dot code is evaluated. If it is evaluated to some true, and if it is evaluated you may result false. So 2 cases we may arise. So that's why this B dot code, this B is B dot code, Boolean expression code, has to be evaluated the first initially for the first statement. S derives if B dot B S1. Now the code results either true and false. true, another one is false. Now the true case holds some label. Here one label B true and B false holds some label. The true case holds the list of statements, that is S1 dot code, and the false list of statements, remaining statements. So that is called a if structure. How that syntax directed translation of law of control statements in case of intermediate code generation, simply by applying the code dot code with the result of the evaluation before placing a marker, and after placing a marker, list of statement that is to be executed. So this is an if structure. Let us see if else structure also, how this implementation takes place in case of syntax translation. See here, second one is S derives if Boolean S1 else S2. Now this code is to be evaluated first, that is B dot code. This may be true, false. So that's why here it is true and false. Now true goes to with the label, false goes to with some label. So what is the true label here? S1. Here true label is S1, false label is S2. So that's why true label S1 dot code, this S1 dot code has to be executed. And after executing S2, it will go to once again S2, not. It won't go to S2. Then it will go to the remaining statements of continuation of the remainder. So that's why after S1 dot code, it goes to S dot next. So S dot next means what is the next? What is the next of this state? This yes. Here S is a place value, S dot place, which holds the address of that one. This variable to the next. So what is the next? Immediately following the next statement. Immediately following the next statement. So this has to be executed with the given by marking this value is the S dot next. So what is S dot next? We have put the one label S dot next. So these statements are to be executed. These statements are to be executed. Suppose in case of the false, that means if the code executes B dot code, if it is a false, then it won't execute this one S dot code, and it evaluates false, and then S2 dot code is to be executed whenever it is false, and then continuation of the, it won't go to next dot next. So here the corresponding statements are not executed. So S2 dot next only, S2 dot code will be executed, and the next statements S dot next is to be keep on executing the remaining state. So that like that the code syntax 3 address code has to be generated for the translation of this flow of control. While structure also used to be implemented with the help of while. See here, yes, this production while, yes, Boolean S1. Now we are going to start with some label, that is begin. Now in this begin, that means here while structure starts, and then the condition B dot code is to be evaluated. Maybe here also it may return either true, false. So the true structure is going to be written, and then the corresponding statements are to be executed. That means S1 dot code. And then once again it goes to the begin. So here go to begin indicates that it goes to the once again the label begin. Again evaluates, if it is true then the same sequence. That means it repeats until all the statements are true. Whenever any condition B dot code false occurs, that means this has to be failed. Suppose if any case this false occurs, so in this case it won't execute the code statements inside this one. It comes out of this while false. This comes out of this one and execute B dot false, and continuation of the while statements which are available. So this is the part of this syntax directed translation course, where flow of control structures can be executed with this varieties of if structure, if else. This is if structure, if else, and while structure. It has to be executed with the sequence of the statements, stepwise manner, but in the table you have seen. See, for example, here in the case of production rules, the same flow of control statements, instead of diagrammatic, that is a notation, a direct translation notation, semantic rule translation notation, how it can be assigned with the this one. So, for example, here P derives yes. Now, what is the code? We have to calculate both the label, that is statement of the next value, with the corresponding statement code. So, both P and S, that is to be first, it has to be, and then go to the label S dot next, and that generate one label. Here, the second statement S assigned, simply it is assigned with the code. What is the code of this one? Simply assigned to the S dot code. This is we discussed in the previous slide. S derives if B S1. Now, first initially a label has to be created with true, and false is to be created with S1 dot next. So here in the previous slide, here S1 dot next, we are getting B dot false. So that is true. So here true label is to be created. So that's why here B dot true, a new label has been created, false S1. Now, after evaluating the code, that is Boolean expression code, maybe it leads to true or false. Suppose if it is leads to the true, then it generates the output of B dot true and the label which is assigned, and the corresponding statements are to be executed. In case of else, that is only if statement. In case of else, that means code is executed, code condition evaluated true, then label goes to the particular block of statements and corresponding S1 dot code executed. But here we have to create two labels, true label and false label. Why? Because a true label generates holds some value, false label which creates the false notation of false statements which are belong to that particular label. Now we have to evaluate S2 dot code, that is what is the code is to be evaluated, that is to be either true, and the corresponding S1 dot code is to be executed. That means it generates label, and once again it generates S1 dot. What is S1 dot code? That is to be executed under. Whereas false, here false B dot code then returns S2 dot will be executed. So in either of these statements, S1, S2, the go to S dot next is to be executed. Then that is assigned to the left hand side S dot code. What is the thing? What is the result? It is to be assigned to the left hand side of the code which is contains the variable yes. So in this way we are going to calculate or write the stepwise or symbolic notation. Previously are written with a graphical notation. The same can be written as a semantic action rules. These are called as semantic rules for that one. So these are the semantic rules for this expression, for this Boolean expression, that is flow of control statement if condition. These are the Boolean expression this for the if condition, assignment statement, and just simply a statement. So like this, we can also write different notations for Boolean expressions, flow of control statements, and while structure also, while structure and S1, S2. So while structure also we have to create a new label first with the new label. That means first a new label has been created before beginning of this one, and then evaluates true, new label false. So whenever true, then automatically the code is to be created with inside S1 dot code. Each time S1 dot code is to be executed. So if it is, and then go to begin. Every time the loop continues with the begin. Suppose if it is false, then it won't execute and go to the next S dot next. That means whatever it will skip off the while loop. If it is false, skip off the Boolean condition, what are the statements which are there S1, that is not to be executed. S dot text is assigned to this B dot false. So it executes the text statements of S following. That means the continuation of S, and then the code has to be continuous with the remaining statements. And we can also have a simple flow of control statement like S1, S2. So in this case, the code has been evaluated with S1 dot code, and after that S1 dot next, then S2 dot code. Means first evaluates the list of statements with S1 dot code, and then generates output, then that is passed to S2. S2 dot code is to be evaluated and then goes to the next S dot next. So like this, the code is assigned with the translation of the Boolean flow of control statements. So this is a very easy and quick manner we can assign. So this is the like this we have seen various examples of the conversions of these translations of Boolean expressions. This assignment statement, first one, we have converted into this one as a production rules we have taken and consider into a semantic actions, that is plus, minus, star assignment statements. Boolean expressions are and not operator, relational operator, logical values true and false, and also sequence of stepwise execution manner before translating the syntax directed translation of the address code notation. And for each of the production, we have written a separate stepwise manner for how this place and temp value code is to be created, which is holding the address of that variable, and then which is assigned the left hand side of the expression to right hand side into a left hand side of the expressions, and then flow of control state structures such as if statement, if else, while structure, and these are to be assigned with the different labels, whether it is putting the markers as a labels before the code of statement after certain list of statements, and this code has to be completed with the expression values the like true and false. If reaches to certain region, that particular code has to be executed. If not, if condition is false, then it is leading to the next go to statements which are making that label, and that corresponding label b dot false, remaining statements are to be executed, and then it skip off the true conditions and then goes to the remaining statements of that particular block of statement. Similarly, here also flow of control as a previous stepwise manner, where sequence how the code has to be generated, how it is assignments, generates of code takes place for each productions, like if else, while. Now, like this, all the contents which we discussed in this can be available with the book, that is Compiler's Principal Techniques. That is the three other book, Alfred's the Willman, and we can find out all these things. Now, we'll come up with the next concept from the next session. Thank you. As the time permits, now I'm leaving the session. Next topic with a new topic, we'll meet once again. Once again, thank you, all of you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.